Hi, thank you for virtually joining my session, Azure Functions in the Dataverse. I'm Phil Cole. I work for DXC Technology and I've been working with the platform since Dynamics 2013. You can find me on LinkedIn, details are there. That is what I used to look like before the pandemic. Now my hair is considerably longer. Um, So a big thank you to our sponsors, as I'm sure you've heard before, but thank you to ScriptRunner, DQ Global, Proximo 3, Redspire, Agilysys, and Hitachi Solutions. Thank you very much. So how did this session come about? Well, I asked a question on Twitter a while ago about what people use to connect to Dynamics as it was then, or the Dataverse as it is now, and what technologies they use from Azure Functions. How do they connect? And got a range of responses from a range of people. So thank you to all that responded. Some quite notable people in there. Thank you. You made me investigate a bit further and where we are today. So Azure Functions in the Dataverse. So what are we going to use Azure Functions for? Azure Functions is a little serverless piece of code that you could use to connect to a variety of different things, but we're going to use it to connect to the Dataverse, and we're going to say this function is given a first name and it's given a phone number, and I need to search the Dataverse for and find any contacts that match the first name and have got the same phone number. But phone numbers can be in all sorts of formats. They can be in all sorts of arrangements. So we need to use a little library inside of the function to sort all that out. It's difficult to do that straight in Dynamics, so that's why we're using an Azure function. So when we find the contacts, we're going to return a little bit of detail, and we're going to return all the contacts we find, and then just some spurious extra data that we may want to use. Just an example. Okay, so there's a number of ways of solving this. We could store the phone numbers in sort of like the E164 format, which is the country code, and then the national code format or the standard format for it. But we're just going to stick with doing it a naive way and trying to match every number as we go through it. There's I want to use that because we can demonstrate a couple of things. There might be a 2-minute timeout that you might get with plugins in Dynamics, and we can exceed that with an Azure function. You've got a 5-minute timeout with an Azure function. And also, you can't use any other libraries or any libraries inside of a plugin or a CWA directly. So you have to use an Azure function, or Azure function is a really good way to get access to all of the other software that's out there on the internet that you could use. Okay, so durable functions are another way of enhancing what you can do to exceed that 5-minute timeout, but we're not going to go into durable functions today either, but that's a good thing to consider as well if you need complicated things to be done. So as I said, the solution is going to use an Azure function that uses lib phone number to normalize the phone numbers. We're going to look up the data in the Dataverse and we're going to return that. And then we're going to make that available as a custom connector. So it could be used inside of the Power Platform. So runtimes we're going to cover. There's a number of different those. Clients, what clients we could use. What identity or authentication we've got of options. And then how we're going to make this available as a custom connector. Okay, so runtimes first. There's 3 runtimes that you've got in the Azure Functions. You've got version 1, version 2, version 3. Version 1 came out first. It came out with .NET Framework time, and it supports .NET Framework 4.7. Version 2 supports .NET Core 2.2, Node, Java, PowerShell, Python. Most of the versions of those that have been in version 2 are going out of support. .NET Core 2.2 ended in December 2019. .NET Core 2.1 ends in August 2021. Node 8 is unsupported. Node 10 is unsupported in April 2021. Python 3.6 and 3.7 are in security fixed only mode. So if you were starting from scratch, you wouldn't use Azure Functions Runtime 2. Version 3 is the latest version of it. It's .NET Core 3.1. and the later versions. It can support other languages as well. So the only real reason that you might use version 1 is if you need to use .NET Framework, and it is in maintenance mode. It is fully supported, as is version 2, as is version 3. They're all supported for production scenarios. There's no deprecation of version 1, but version 1 is in maintenance mode. That means no enhancements, no fixes, no changes. So what is an identity and how do we use it? Well, we need to connect to the Dataverse. We need to have a URL where the Dataverse is. We've got one of those as soon as we start a Power Platform or Dynamics instance. And then we've got a number of different ways that we can identify ourselves to it. We could use an app registration, and we get a client ID and a client secret. Client ID is similar to a username, client secret similar to a password. Or we could use a managed identity, and we'll come on to those a bit later. They could be a system assigned managed identity or a user assigned managed identity. And then to connect to the Dataverse, we need to have an application user in the Dataverse, and we need to have a security role assigned to that application user. So let's go through this. At the bottom of this presentation, I'll be including lots of links, refer to lots of places and people, and so in Azure App Registration, there's a link on the bottom for the Docs website. But to create an Azure App Registration, you go into Azure, go into Azure Active Directory, App Registrations, and then click the New Registrations button. You give it a name, you say who can use it, and then you press Register. And then this will give you an application ID, and then you need to, so that's a username or a client ID. It's known as a client ID. And then you need to create a client secret. So we go to Certificate and Secrets, new client secret, and then we can give it a name and when it expires, by 1 year, 2 year, or never. When it expires, it will stop working. So then we've got a client secret. You'll see it one time only, and you can copy it and use it where you need to use it. Now we need to create an application user in Dynamics. So an application user in Dynamics, this is the only time you go into the classic interface to create a user. You go to the user screen, and then you'd need to look at all the list of users, and from that list, you need to change the view to the application users view. And then once you're in that, you can press new, and you'll get a slightly different form come up. And this form has changed recently. You used to be able to enter into the name field, the full name, primary name field. Now the only field available is the application ID, and that's the application ID or the client ID that you got from the app registration. So here, so you put that in, and it goes away. It looks up in Azure. There are other details, gives you a username, and it does put in a user-friendly full name, so it appears nice in when records are created or owned by it. And then you have to give it a security role. Now, recommended to give it security role with just minimal privilege on it. So perhaps create a security role specifically for the application user. Okay, so we're done. So now we need to create some clients. So there's a number of different ways that we can connect to the Dataverse. We could do it via HTTP because we've got a web API endpoint that we can connect to, or there is a long deprecated SOAP endpoint, which you might mention as we go through. So you could use HTTP or you could use Crm Service Client. Crm Service Client is part of Microsoft's XRM tooling. You can use that. It's fully supported. You can use that in Windows applications, or you could use it via Azure Function. We've got CDS Service Client, which is a slightly newer version of that, which we'll mention in a bit. We've got Odata Client, symbol.odata.client, Odata Connected Service, and there's lots of other options for connecting via Odata or the web API. I use the term interchangeably, perhaps I shouldn't, but I will. So we've got CDS Web API service. That is, you'll find that in the Docs website, Microsoft Samples, and then xrm.tools.web API. That's from David Yak, and you'll find that on his website. So you could use plain HTTP, but if you do that, you need to re-implement at least some of the authorization, at least some of the verbs, pagination, page handling, error handling, and if there's any retries due to reaching API limits or service protection limits, i.e. you get a 429 HTTP error, and that will maybe give you a retry again in X number of seconds, minutes. So it's maybe time consuming to implement, but if you're doing something very simple, then it may be a good option. Plus, if you're using something for doing something complicated, then you don't get strong typing, which is one of the, well, people have strong opinions on whether that's good or not. But I was pointed out today, and perhaps I should have known about this earlier, but Mark Schweiger on Twitter mentioned that one of the options to use is the app service token store, and in the same way that you might use a connect to the Microsoft Graph, you can connect to CDS or the Dataverse, and when you've got an Azure function, you can turn on the app service authentication. Say the application provider is AD, and then set it so that it can grant Common Data Service or Dataverse permissions. I haven't got a working example of this. There will be one on my blog when I get this working. Another option, again mentioned by Mark Schweigert in my original Twitter question, was a simple Odata client. So this is a very widely used Odata client, can connect to lots of Odata systems. It's lightweight. It will talk just REST over the wire. It's well supported. Just Web API. You have to be familiar with Odata and Web API. I think that's getting more. People are becoming more familiar with that. If you have issues with that, or you need help on that, then there's always the excellent Fetch XML builder and a number of different options in there to generate the queries in Web API format. So the authentication needs to be handled separately, or you need to roll your own authentication, but it is asynchronous, which is a good thing with Azure Functions. So an example of it, you probably can't read that, so it's slightly bigger. So this is a bit of code with help from Nishant Rant's blog. Thank you, Nishant. Most of the code in here wouldn't be able to be written without other people's help. So again, thank you to the whole community. So here we've got us using a client secret and a client ID, and we get those from the environment variables of the Azure function. And that could be in a key vault, but that's or it could just be in the environment variable. Recommended a key vault if you're going to use client ID and client secret. Tenant ID of the Azure AD, and then we build a bearer token, and here we use that bearer token, and we use that before we make any request. So eventually we get an Odata client that we can actually use, and then when we use that, we can, here we are, that's the client, and we use the client again, and then we can just use it to get contacts where the first name is like Robert, say, and then we can just output a list of those to the log. So that's a simple Odata client, just a simple way of connecting to Dataverse. Another way is Odata Connected Service. So this again is Mark mentioned this on Twitter. So this will generate strongly typed. The other versions not strongly typed. Some people prefer having strongly typed, especially when you've got a highly custom system where fields might be changing or morphing over time. OData Connected Service, strongly typed. It can use .NET Core or Framework. You might have to fix some of the casing that's generated at the moment. If you look at Mark's Twitter, then you'll see more information on that. And it will generate a high number of types. So if I were to go away and connect to the Dataverse and it pulls back all the list of types that are there, if I deselect all the types and just select contact, it's and that selection of what contact on its own will pull in 519 other types. So maybe that's good, maybe that's not good, but because contact is a well-connected entity, that's what happens. So how do you use it? Use it in a form similar to this. So we've got a connection to the Web API endpoint, and then we would use the provided classes, and then you get a link type statement here, and you can then just output the outputs from it. So you need to get a token to be able to use this though, and that will ideally be via ADAL, but it'd be similar to we looked at in the last one. So Crm Service Client. Crm Service Client is based on .NET Framework 4.72. Therefore, we must use version 1. Internally, it's still using the SOAP endpoints from 2011, but it is being slowly migrated over to the Web API. Thing about this is it's a familiar style, low-level familiar style that long-term Dynamics, CDS, Power Platform people may be familiar with. And that allows a common style of code between plugins, CWAs, and Azure Functions, which companies may or may not find a benefit. It allows various methods of authentication, client secret, certificates. I'm not going to go into all of them. But it does perform 429 error handling, so that it will back off to a point if it gets a 429 error, say the platform is heavily loaded, you're hitting API limits, then it will wait until the time given on an error 429 to try again. It supports a link, or it's got a link provider in it. There are some limitations to it, but it does support link, and it's synchronous. So synchronous, not too brilliant for an Azure function, but it is workable. Now, if you're going to use Crm Service Client, you have to change the version of the runtime manually back to version 1. Otherwise, you'll have problems. And so that's important to know. Okay, so Crm Service Client is probably the most common style that people may be aware of. You've got the Dataverse URL, which is coming from an environment variable. We've got client ID, client secret, and then what we just looked at a while back when we got those from an Azure app registration. And we can create a new client just by passing the URL, client ID, client secret to Crm Service Client, or we could use a connection string. Both will do the same. Then we can check if the client's ready, if there's any problems, and if not, we've got an organization service we can use to create and check out who we are. CDS Service Client is alpha. It's not for production use at the moment. Namespaces may change. It supports .NET Core and .NET Framework, and it does use the SOAP endpoints, but again, it's been migrated to use the Web API. It's virtually unchanged from the Crm Service Client, so it's for familiar style. Same authentications are implemented. Error 429 again is supported. Supports link, but only just recently it now has asynchronous support. So that's particularly interesting. Haven't yet tried it out, but that's good news. But again, it's alpha, so I'm not going to cover it too much more, but it is part of where the future is heading. So I mentioned managed identities at the start, and we said we've got two types. We've got user assigned and system assigned managed identities. Now, why might you be worried about a managed identity when we know who we are? Because we've got an app registration, we've got a client ID and a client secret. Well, they're like a password. So a client ID and client secret are like a password. So if somebody actually gets those, then they could authenticate to the system, and really don't want to have to store those. If you could do away with them, that's better. So a managed identity is a way of doing that. Thank you to Eugene van Standen for his excellent blog post on it. Recommend you have a read of that as well. So when you have an Azure function, you can, by default, it will create these days with a system assigned managed identity turned on. And when it does that, it actually goes away and creates an enterprise application. So if you were to search in Azure and go to enterprise applications, look for all applications, and then change the application type to managed identities, it will show you there will be a created managed identity for each Azure function. And alongside, you get an application ID in exactly the same application ID style that you might have if you were creating an app registration. So you could use that inside of Dynamics to create an application user, and then assign a security role to it. Now, previously, it was possible to update the application ID, but that's no longer possible. So maybe it's now useful to use user-assigned managed identities. So user-assigned managed identities are where you can create an identity in Azure, and you can assign that identity to an Azure function. But so that's slightly more complicated. I'm not going to go into it today, but user-assigned managed identities may be useful as well. So we had our environment variables. We can see I've just been talking about the environment variables, but I wanted to show you where they're set inside of Azure Functions. You go to the configuration, you get the application settings section, and you press new. So you press new, and then you can put in the Dataverse URL. Now you could store this in the Key Vault, or you could leave this open and store it just as an environment variable. It's up to you. So now we've got a question. Okay, so if I've got a managed identity, I haven't got a username and password. So how do I tell if I'm debugging these Azure functions? How do I tell the system to use to work, to run as me, or to run as a particular user? So if you use various libraries that are going to show you, you can log in with either Visual Studio or VS Code, and the libraries will go through and they'll try out from system managed identity through user managed identity, through Visual Studio, through VS Code, through down to Azure CLI, maybe a little bit further, down to Azure CLI, and then you can log in with Azure CLI like so, and it will say you've logged in, give you proof that you've logged in. I like doing it via this because I know it's happened and I don't have to be concerned about what Visual Studio or VS Code is doing, and that works well for me. Then we'll come on to how this plays out in a moment, but it's useful to know that when you're debugging, if you're using the libraries, then they will give you the option of whether you want to use a managed identity or whether you just want to use Azure CLI or VS Code or to work with. Okay, so we've logged in with Azure CLI. Okay, so now we need to understand how we're going to use a managed identity. So there's two things to it really. There's an Azure Auth provider and a CRM client override hook wrapper. But first I'll go on a little diversion. You remember at the start we said we were going to look up the details of a contact and we're going to provide a little bit of information about them. We need that because we want to demonstrate a complex entity coming out. So we've got a contact, the contact's response, contact ID, full name, last name, first name, mobile phone number, and then a list of journeys. So the journeys are defined from the date, from, to, and the journey type, which is an enum. Okay, so how does this run? So I'm not going to go into how it works right now. We're just going to run it. So we run it, and we look at the output, and we've sent in two parameters. The first name is Robert, and the phone number is the number, and we can see that it doesn't match exactly any of the numbers, but lib phone number's done its job, and we can see that we've outputted two JSON objects in a list with the journeys inside as well. Okay, so how does that work? Well, here's the code, but you can't read that. So we're going to look at that in three parts. We're going to look at the top, bottom, and middle. So we've got the code that reads in the parameters. It gets past the number and the first name, and it throws an error if we don't get both of those parameters. So that's pretty standard. At the bottom, we've got the normal sort of style that you might write code and talk connect to Dynamics in the plugin. We've got code here which is getting a service context, and we're using Darrell Labar's amazing early bound generator to generate the service context just for the contact entity. And then we're going away, instantiating our lib phone number, doing a link query, and then adding in some extra fictitious journey information, and then outputting that list of contacts and their journeys in a JSON output. But the bit in the middle is the interesting bit. So how do we connect to the Dataverse? So all we do first off is get the URL for the Dataverse from the environment variable. Then we look up another environment variable, which is a token provider connection string, which we'll come on to. We give that to an Azure Service Token Provider, and that informs it how to look for tokens, where to go to look for tokens, and then we override the auth on the Crm Service Client. And then we call the Crm Service Client, and we adjust the Dataverse URL. And then when it's ready, we carry on and do the stuff at the bottom. So if we look at what is this token provider connection string, so that tells that's in local settings, just when you're running on your local machine as a developer. You can run as a developer, and you can use the Azure CLI authentication. So that's all it'll check for to try and authenticate. When it's in the cloud and you haven't got that environment variable set, then it will start down the path of looking at a managed identity, system managed identity, user managed identity, and so on. Okay, so the final part is the token. So this here, we've got a token provider, and then we have an auth wrapper. So this auth wrapper, we have passed it the token provider, and this is the Crm Service Client. Gives it a URL, which is the URL that it has itself. So at the moment it's this, and I don't think the latter half is used, but we strip it off anyway, and we get a token for it, and we just use that token that we're given. So just to reiterate, the advantage of this is that you don't have to have a client ID and a client secret. You can do away with those. The Azure function is identified by Azure, and it can authenticate into Dynamics because the application ID or the client ID of the Azure function has been created as an application user inside of CDS, and we've got a token that works. Okay, let's just take a step backwards and consider the design and definition of APIs. So there's probably two schools of thought. There's maybe the API first school of thought, where you might design all the APIs in advance and publish them, after which some code is written or maybe even generated that fulfills those APIs. And then maybe there's the code first approach, where maybe the API wasn't considered when the code was first written, and so maybe the API is an afterthought. I'm not sure if this particularly applies with Azure Functions, but perhaps there's a balance here. So I think an overarching design of APIs and their interaction is needed. before starting work on any APIs. But I think you need the ability to flex and change as needed as maybe a design evolves. So perhaps putting the API definition within the code could be considered useful. So with that in mind, let's think about a custom connector. What does a custom connector actually do? Well, it's got an endpoint, which could be any web service. So it could be an Azure function, could be something else. It defines what's available within that custom connector. So what can be called, get contacts maybe, list contacts, delete contacts, you name it. It defines the inputs and outputs from each of the available functions. So in our example, maybe it would be the first name and the last and the telephone number of the person that you want to look up or find, and then the layout of the columns that will be returned and how they might be presented. And then it may also specify the authorization methods that be needed. So how does this fit with what we've been talking about? Well, we could create an OpenAPI or Swagger definition from an Azure function by using some libraries that were created by Justin Yu, who's now a Microsoft Cloud advocate. And his libraries are Azure Functions.extensions. They're available on NuGet and GitHub. It's open source. And it allows the decoration of the Azure function. So with that, it also embeds the Swagger UI. So we'll come and take a look at that in a moment. And it generates an OpenAPI definition for you. It also gives you a UI to interface with locally or within Azure. But there's a few caveats with it, especially regarding support for Azure Function Runtimes version 1. However, it does support version 2, version 3. Okay, the links at the bottom are very useful. And for me, it all started with his blog, which is a very interesting blog, and I'd recommend taking a look at it. Creating custom connectors from Azure Functions with Swagger. So how does it fit together? So we need to install these two NuGet packages into our existing Azure function. If you do that, it adds an OpenAPI folder, which has got some new endpoints that can be, or some new functions that can be launched, and it's an OpenAPI settings file needs to be created as well. So these are the functions. This is particularly the one that's delivered with it for version 1. This is the trigger, and in there this will actually generate the functions that will generate the Swagger and the Swagger UI, or generate the OpenAPI definitions in a number of formats, version 2 or version 3, or in YAML or JSON format. You'll see that in a moment. And then the OpenAPI settings.json file, that is meant to be adjusted and customizable to meet the requirements and document the API. And we'll see where that comes out in a moment as well. So what do you do with it? Well, this is our function that we were looking at previously. And we've got some new usings at the top of it, not particularly a huge amount. And then we've got some decorators. So the first one is explaining that we've got a new operation of named get contacts, and we've got a summary and a description, and we've got the visibility, which is we've got the visibility, and that's important. And we've also got the input parameters that are taken, so the first name and its type of string, and the number, that's a type of string, and we've got some descriptions about it and whether it's needed or not. And then we've got the outputs that are outputted from it. So in an OK response, we'll output application JSON, and we'll output a body with type of a list, of our contact response. So this will be a complex object. In this case, it's a nested object as well. And Newtonsoft will serialize all of that into a nice JSON object. Again, we've got without body, so another decorator here. API response without body if there's nothing found. Again, if there is a without body but it's a bad request, we'll just return plain text of type string. And if we've got an internal server error, then we'll output that as well. It's just plain text. So that's all we've had to do to the Azure function to actually to decorate it. But so what does that give us? Well, if I run it, so within Visual Studio or wherever, if I run it, I've now got a load more functions in here. I've got my original get contacts, and now I've got these additional ones. These are the OpenAPI file in version 2, version 3, and then the Swagger. And we've got Swagger UI. So if we were to go to Swagger UI, if we were to go to that API Swagger UI location, we would see something similar to this. So I've got this is the information that was in the local settings. Sorry, not local settings. This is the information that was in the OpenAPI settings, and we can see it here. And then we've got the functions, and we've got the models that could be returned. They're ready for information. But if we were to click on get, it'd expand, and it would it'd show at the top of the screen. It showed the parameters, the first name and the number. A button here to try it out, and then the responses. So we scroll down, we'd see that 200 code would be match contacts, and it'd have a format something along those lines. Obviously, there might be more than one of those contacts that are returned. Error 400 or bad request, the message, and then you get a string out 404 and then a 500, which never happens. And so this is quite useful to explain what might be output from the Azure function, and you can see that immediately it's converted it into some and taken the typings and given them sensible values. Like a GUID's got a GUID output from it. And also, if we were to go to the swagger.json location, which we can get to from the top here, or you could go to it directly, you'd get a Swagger file or an OpenAPI file. I keep calling it its old name Swagger, but it's OpenAPI these days. So this here is really useful because we can take that into our custom connector straight away. So I'll show you that. So if we were to save that locally or copy it to the clipboard, and then we went into the Power Platform, and we went into a solution, and we created a new custom connector. Say we created a custom connector, person find a custom connector, and we gave it a name, and we turned the Swagger editor straight away, straight on, and we get an empty Swagger definition virtually. And if we paste what we've got in there, so paste our clipboard in there, it will say, do you want to convert this to YAML? And we say yes. And then our definition is completely within here. We can see on the right hand side, this looks exactly like we were looking at it in our screen. We've got get contacts here. We haven't done one final thing, which is to set the endpoint. So where is this actually going to talk to? So that's our Azure function in the cloud, and then we would specify that. From that point on, we can save this, and we can use this as a custom connector. Now that was great, but with everything good, there's always a caveat. So I mentioned at the start that Azure Runtime v1 is in maintenance mode only, and the runtime for Azure Functions v1 includes Newtonsoft.json version 9.0.1. And that's fine for older versions of Crm SDK, Xrm core assembly, and because they only require Newtonsoft 6.0.8. But recent-ish versions of Xrem tooling require a more recent version of Newtonsoft, and this is baked into the Power Platform. So there's a clash between what the Power Platform needs and what Azure Functions Azure Functions Runtime 1 will need. And because that's to do with serialization, and so because that's to do with serialization, and because we need to serialize the inputs and outputs, and also the definitions, that causes problems. And the Azure Functions OpenAPI extension doesn't work directly in Azure Functions version 1. However, so with that issue in mind, there are three options really. You can remain on an early enough version of Crm Service Client so that you don't need to upgrade and don't encounter that issue. Everything works straight away on Azure Functions version 1. Or in the blog post linked at the bottom of this screen, there is instructions on how to use a second Azure function as a proxy. So a version 3 and a version 1 Azure function, so that you can call the CRM service client without having to have a later version of Newtonsoft in play as well. Or finally, you could just rewrite the Azure function in in OData, so that you're freed up and not having to use CRM Service Client like we saw at the very start of this presentation, and that may allow you to move to .NET Core 3, where Azure Functions extensions does work. Now, also it should be mentioned that Microsoft are working on a similar version of a library to this. The link is at the bottom of the screen, and that only supports version 2 and version 3 of Azure Functions. So it's not quite there. Well, it's not there for a CRM Service Client, but it will be useful for CDS Service Client, and it's something to consider going forward. At the moment, it's in early stages of development. It's 0.4 a preview release, but it's something to keep your eyes on. So where can we enhance what we've looked at today? Well, we could consider dependency injection, so something like AutoFac in V1 land to move the code that creates a client, a CDS service, CRM service client, into a single location and provide it to each function rather than having to create it each time. Or we can also look at unit testing. So we can put unit testing in there with fake Xrem easy, Xrem mockup, Xrem unit test, one of the general functions, especially if you're using CDS CRM service client. And I'm sure there's plenty more. So what does the future look like? Well, it's probably CDS Service Client, async Web API, or it may be using one of the Azure Functions OpenAPI extensions, or it may be just more of a more OData, a friendly way of working. It looks like there's going to be more a use of Azure API management to expose custom connectors. And there are some intriguing solution components that are not documented anywhere at the moment. Application user role, application user profile. So in summary, what have we learned from today's session? Well, use OData if more familiar, or if it's for simple scenarios, it may be easier. Use CRM Service Client if you want a consistent style with plugins, early bounds, and unit tests. If you want an upgrade path, then CDS Service Client looks like it's going to provide that. Use managed identities to avoid secrets expiring unexpectedly. You don't want Azure Function to stop working because the secret's expired a couple of years after somebody created it. And consider using AlienCube or Microsoft OpenAPI extension to generate an OpenAPI definition. But if you're using Azure Functions v1, beware of the Newtonsoft version conflict. So you may need to proxy or work around it. And finally, consider using dependency injection to provide a client to the function body so you don't have to repeat code. Thank you for attending. Well done for lasting this long. All the code demonstrated today can be found on my GitHub. My contact details are there if you've got any questions. Thanks.